Hello again, everyone. It's Bob Martin, the RCSubGuy with the Nautilus Dry Docks, and today we're going to be talking about an often overlooked but very underappreciated tool in your RC submarine arsenal. Let's talk about magnets. So as I mentioned, we're going to be talking about magnets today and all of the different uses that they have for potential integration in your RC submarine. So I'm going to be talking about some things that you probably are aware of and some things maybe that you haven't thought about. We'll talk about what you can use them for, and more importantly, what is the best practice for installation of them so they stay stuck in your boat. Let's get started with one of the most common uses, and that's as a magnetic hold down for the deck of your boat. So one of the easiest ways to illustrate that is with a boat that we do have here that already has magnetic deck attachment integrated into the boat. This is our 1/48 scale Arc Model Type 7 kit, and as you can see, it has a flat deck that goes over the entire thing. Now you want to have access to the interior of your boat. Rather than having screws that come all up through the top part of your deck, you can use magnets. And those will be fully concealed and still do a great job of holding the deck down. So let's take a look at how this particular builder, Mike Martin, used the magnets to hold down this forward section of his deck. So you can see this is normally down, this ends up sitting flush, and you can just peel it back and you've got a couple of magnets that are holding it down. So he's got these blocks in here that he's drilled in holes, press fit little disc magnets, and then in the boat itself, you got the same thing. You've got these flush mounted disc magnets or cylinder magnets that have been press fit and are flush with the mating surface. So when you go to put this on, you just kind of drop it down, press it down, and it's locked in place. Really easy access to the boat. In a minute, we're going to talk about the actual implementation of that and the best way to get those adhered to the boat so they don't pop out. But that's the first implementation, holding down the deck of your boat. The next implementation is also one that you're probably familiar with, and we've got a product here at the dry docks called click-ons, and these are magnetic linkage connectors. So with a removable watertight cylinder, you want to have a way to connect the servo outputs to the linkages of your boat. Traditionally, you would end up doing that with a physical connection that would click or lock in place, that you would undo with a tool of some kind. But these magnetic connectors are a little bit different in that you need no tools and you still end up with an exceptionally positive connection. So if we take a closer look at these, we've got two different styles here. These ones here were manufactured by David Merriman and were shipped with his subdriver watertight cylinders. We've got an equivalent product, the small click-ons, and these are our large click-on connectors. So you just simply attach this side to your servo output of your cylinder, this side to the control surfaces, and this is the connection that they make. And you can see I need to put quite a bit of force in order to separate these. And because they're so strong, they also have a lot of really good torsional stability as well. In practical application, when you drop the cylinder in your boat, what ends up happening is these magnets kind of see each other and they lock into place automatically without you even needing to physically make them up. A little bit of an example you can see here in this Gotland class submarine hull I have. So this is a solution that this builder engineered. Same sort of thing, magnetic connectors. And he's got a set screw in here that would connect to the rear control surfaces. So these would just snap right on. And as a little hint, if you make sure that the polarity of the two outputs in the rear of your boat, your rudder and your rear dive planes, are switched or opposite each other, then the linkage connectors will always jump to the correct output. So if you have two that are close, just to make sure they don't connect to the wrong ones, you can always make sure they get to the right place by making sure that your polarities are reversed on the two outputs, and your linkage will jump right onto the correct one. Another potential use of magnets may be that you haven't thought too much about, but that we've successfully implemented in a lot of our builds, particularly the big Baleo class submarine that we're finishing up. These are waterproof compartments rated to about 80 feet of depth, and we put a lot of our control components in here for large submarines. Now you need a way of mounting this inside the cylinder, or inside the hull, sorry, in such a manner that it's not going to move. And we used magnets for that purpose. Friction fit cylinder magnet in the bottom. Now I did not drill all the way through. The walls of this container are almost 1/4 of an inch thick. So you can see it's protruding about 1/8 of an inch. On the mating surface, we drilled that 6 mil hole, and you'll see here in a moment that we drilled a larger hole, which means it's not going to be friction fit when this container mates down. So in practical application, you'd have 4 mounting points. You drop the box in and it snaps down. Now it can't move forward, backward, left, or right, and it doesn't want to come out until you pull hard and it comes out. If you're creative with the polarity, you can also make sure that you mount the box properly every time so you don't reverse it by making sure that you reverse the polarity of the magnet. So if you have it installed incorrectly, it'll just push itself back out again. Another potential implementation for those of you with a little bit more engineering skills, perhaps, and that is magnetic output for linkages from the watertight cylinder. So the main goal of this is to create an end cap that has no perforations in it. So in this particular case, those brass output shafts are completely sealed. There is no seal in there whatsoever. It is completely enclosed with no perforations whatsoever. This was a magnetic linkage connection that I came up with that uses cylinder magnets inside those brass tubes and then ring magnets on the connector on the outside. And the idea behind this is your connector slips over, that's actually pretty hard, and kind of locks in place. It's sandwiched by magnets on either side there. So it's really, really stiff. And then you take your click-on connector that we talked about earlier, and that snaps right onto it. And now you're connected to the boat with no perforations in the cylinder that could potentially leak, cause you issues in the future. Speaking of no holes in your watertight cylinder, of course the other thing that you've poked a hole in your end cap for is your main drive shaft coming off your motor. Now there is a solution for that as well, and that's a magnetic drive coupler. And this is something that I fabricated years and years and years ago. 3D printed parts with a series of disc magnets that are press fit in there with alternating polarities. And so these snap on to each other. And now when you try and twist the one, it wants to fight it because those magnets are all pushing against each other and pulling against their partner on the other side. We recently came into possession of this Gotland submarine where another builder attempted the same sort of implementation. I want to show you what that looks like here. So in practical application, this drive shaft slips back and you can see, I'm going to pull the coupler off. He went with 2 very powerful magnets in there, but you could easily switch the polarity and put 2 more over here, as well as the mating surface on the other side. So this slips on here. Now note that pin does not go through. That is not the drive shaft. That's just an orientation pin, an alignment pin. So this slips on and it locks in place. So now you can see when I spin this, the motor inside, this big brushless motor, is spinning. And it's quite a positive connection. Some neat things about this particular setup, if you ever do end up in a situation where you're over torquing the motor or the motor gets fouled, what will end up happening is that magnetic coupler will actually slip. It's like slipping the cogs of a belt. But it'll just slip rather than creating massive strain on the drivetrain, the propeller, or the motor. So it's an interesting way to create a little bit of a fail-safe in your system in case your prop ends up getting fouled on weeds or fishing line or that kind of thing. So the idea behind this is you've got this coupler on the one side, a matching coupler on the other side of the bulkhead, and then the two kind of talk to each other through the wall with no hole for water to get through. So let's talk about the kinds of magnets that I like to use. Now these are rare earth magnets, neodymium magnets. I prefer to standardize all the magnets that I use here. These are 6mm diameter cylinder magnets. I use two different sizes, the 6x6 and then the 6x2mm disc magnets. These big magnets, relatively big magnets, are quite powerful, as I mentioned before. The adhesion strength means that they can actually lift 1.5 pounds off of these tiny magnets, which means if you're utilizing them for deck hold downs or for control box hold downs or for building magnetic linkages or magnetic clutches, you've got a lot of force there to work with. Don't buy the cheap magnets that you get from like Home Depot or, you know, craft stores or that kind of thing. These are the real deal. If you have a hard time finding them, let me know. I can probably hook you up with some. One of the best ways to ensure that your magnets don't come out is to engineer a press fit solution. So this is just an example, a piece of standard plastic that I had here and the magnets that we typically use. Now this is a 6mm by 6mm cylinder magnet, and I drilled a 6mm hole in this piece of plastic. And you'll see I can't press this into place with my fingers. So all I'm going to do is grab some pliers, pinch that in, and then I can press fit it down into the plastic. Now, without any sort of adhesive whatsoever, you have a very positive connection between the magnet and the piece of plastic that shouldn't come undone. Now, obviously, you can also use a little bit of adhesive to make sure it doesn't come out, but that is a great place to start. You want an interference fit, or a friction fit, I should say, to make sure that those don't come out. Now, if for whatever reason you drilled your hole out to the point where you cannot friction fit the magnet in there, then you need to get a little bit more creative in the installation of the magnet, and I'll show you how we do that. You're going to need a file or a rotary tool, some cyanoacrylate glue, and some baking soda. All right, so in this particular case, this hole was quote unquote accidentally drilled out too big. You can see this magnet just kind of like falls through it, like, oh no, we're screwed, right? Not necessarily the case. We're going to pretend that we've press fit this one in correctly because we knew what we were doing. This is flush, completely flush right now, and this is going to be our boat. All right, so that's going to sit on the bottom. This is going to be our deck. So we're going to use these little 2mm disc magnets for this particular purpose. And now what you need to do, because this is a perfectly smooth surface, you need to rough up the exterior of the magnet. As I mentioned, you can use a file. I like to use the cutting disc, just lightly scuff the outside of that magnet. You can also use coarse sandpaper. It's easier to do if you do them all at the same time. Stick them together so you're not trying to hold a little tiny magnet. So I'm just going to do that right now. Enter fast forward mode. All right, if you take a really close look at these magnets, you can see that I've scuffed them up, but I didn't grind all the way down to the magnet itself. I only roughed up the coating. Now, if you do, it's not the end of the world. It just means that these are going to be prone to rusting, which is not super cool. The other thing I'm going to mention before we go any further, this coating you can actually solder to, but you may not want to do that because heat destroys the magnetic properties of a magnet. So if you can do it quickly, very quickly and ultra concentrated, you can solder these to like brass, for example. I wouldn't recommend it unless you're very experienced with soldering and you have the proper tools. Okay, so I'm going to keep this on here right now. This is the, and I can just press it in and then slip this to the side, and now we've got a magnet in here. Now this is a 1/8 inch piece of plastic, so I've got a little bit of room in there. If the bottom is flush, there's like a little divot in the bottom. It sits a little lower. So I'm going to check the polarity, put it on there, put this in, and now what I'm going to do is we're going to run our CA glue in there and glue this in place. Now, because I've got a big gap, I'm actually going to use medium CA because I don't want my glue to flow down and fuse these two parts together. That would be super awkward and not good for anybody. So we're just going to tack it in place with a drip on the one side and a drip on the other side. And then we'll we'll flash it with some accelerator. Let that kick for a couple of seconds. And then in theory, you should be able to pull these apart. And they can. So now what you can do, now that these are fused, you can pull this apart, fill the rest of the seam here with the CA glue, and then in theory that will also seal your ground surfaces, and it'll finish fusing that magnet to the substrate, to the plastic. Now that we've done that, I'm going to show you one more thing that you can do if you're using really powerful magnets and they end up coming out on you. So you don't want that to end up happening. Let's talk about that one. All right, like I mentioned, whoops, hole's too big. We got our magnets, we ground down the outside, we keep doing it, but man, these magnets keep popping out, or we're using some really powerful magnets and they keep sticking to each other and pulling out of my deck or whatever. So we don't want that to happen. Same thing, what we're gonna do, check the polarity, make sure we glue our magnets on the correct way. All right, so what we're gonna do, we're gonna make sure that we got our polarity correct, pull it out, we'll note that polarity, so it's on my pointer finger, and then I'm gonna push it into the mating surface on the correct side. Now, I'm gonna push it down so that it's recessed, and this is about 1/16 of an inch in this particular case. And we're going to use the medium CA and we're going to glue it in place now. So we got that. I'm just going to wipe this clean, hit it with some accelerator. Now it's tacked in place. So we're going to now have a gap of about 1/16 of an inch between these two mating surfaces. And the challenge is we want to make sure there's no way for that magnet to get out. And what we're going to do to make sure that happens, we're going to use our baking soda, drop it on top, scrape it flush, and then you put a drop of thin CA right in the middle there. So that immediately kicks off. What we've done is we've created a pocket that that magnet is nestled in now. And what we can do is just grab some sandpaper. If there's any excess CA, you can just sand it right flush. So now this is a perfectly smooth flush surface. The magnet is embedded in the bottom and it'll still have a very positive connection to your deck. There's no way for that magnet to come out unless it breaks free of that cyanoacrylate shell that you created. That's sort of the last ditch attempt. If you've got really powerful magnets or your magnets keep coming out, just recess them a little bit and put that shell over top. Well, there you go, guys. A few uses of the wondrous material known as magnets that you can implement in your RC submarine if you want to try something a little different than your standard mechanical connectors. I hope you enjoyed this. If you do like this video, please do like and subscribe. I got videos like this that come out all the time. You don't want to miss one. It helps us out a lot if you do hit that like and subscribe button. With that, I'm going to let you go. This is Bob Martin, the RC Sub Guy with the NautilusDryDocks.com. We will catch you next time.